Okay, here are the notes for section 6.5, testing a claim about standard deviation or variance, so sigma or sigma squared. So here's our objective. So n is our sample size, s is the sample standard deviation, s squared sample variance, sigma claimed value of the population standard deviation, sigma squared claimed value of the population variance. So we have to have a simple random sample, and we have to have a normal distribution. So our test statistic is the chi-squared, so n minus 1 s squared over sigma squared. So, example 1, listed below are the heights in inches of a simple random sample of supermodels. Consider the claim that supermodels have heights that have much less variation than the heights of women in the general population. Those are 0.01 sigma, so our alpha 0.01. Test claim that supermodels have heights with standard deviation that is less than that. Okay, so our hypothesis, or null hypothesis, is that the standard deviation is equal to 2.6. Our alternate hypothesis, supermodels have heights with standard deviation that is less than, so sigma is less than 2.6. Okay. So let's see here. So we need some numbers here. So we need n. In this case, there are 10 measurements here. We need s, which I let my calculator handle, is 0.7997. And sigma is what we're testing. That's going to be 2.6. Okay. So our chi-squared is equal to n minus 1, so 10 minus 1, s squared, 0.7997 squared over sigma squared, 2.6 squared. So our chi-squared value comes out to be, let's go back to the calculator, fraction 9 times 0.7997 squared divided by 2.6 squared, 0.851. Okay. So we're going to look up our critical value from the chi-squared table, and we'll use that, blah, blah, blah. Yep, doesn't really matter how you draw the shape. So we have less than, so we have a left tail, so our rejection area is down here. So the critical value is 2.088, so using that alpha and that n to find our degrees of freedom. Okay. So chi-squared does work a little bit different because it's 0 is actually over here on the left, so these always just get more and more positive. So this one does fall in our rejection region. So we reject 0, which means so there is sufficient evidence that supermodels have smaller standard deviations than the general population, because we reject the fact that it is equal to the general population. We accept H1. So it is likely that that is true. But there you go. And that is the end of that section, just one example.